Hello students, this is our second class on Java programming, Unit 3 of PGDBI T4. Today's topic is Java classes and inheritance. In the last class, we have discussed about classes. Class is an entity we have discussed. From a class, number of instances can be created and each and every instances can be called as object. Class is an encapsulation of attributes and methods. That means in a class, there are attributes or the properties of the class will be there, which are also known as the variables, and some methods. Methods means, as I have told you people, method is nothing but the function. A method performs a specific task. So in the example you can see here, we have figure. Figure is the class. And we have created 3 objects out of the figure. Circle is one object, rectangle is another object, square is another object. So what is the main objective of classes and declaring classes, class definition, and creation of object out of it? The main objective is actually the reusability. Reusability is a property of any object-oriented programming which supports reusable code. That means if a programmer writes any program, that program can be reused by that programmer or any other programmer of the world. So that facility is very good facility in object-oriented programming. Syntax of the class, as we have seen in the earlier classes, that a class will have a class name and it will consist of variables which will be the attribute of that class only. It will have a constructor function and methods. So that is the composition of a class. What is a Java constructor? A constructor in Java is a special method that is used to initialize objects. The constructor is called when an object of a class is created. It can be used to set initial values for object attributes. For example, color of a car or model of a car, etc. Note that the constructor name must match with the class name. That means if the car is the name of the class, the constructor name also will be the same thing, that means car. And it cannot have a return type. We cannot write any return type for a constructor. The constructor is called when the object is created. A constructor is automatically called when object is created. The main objective behind constructor is to initialize the variables, initialize the member variables of the class. All classes have constructors by default. If you do not create a class constructor yourself, Java will create for you, but that constructor will not allow you to change the initial values of the member variables or object attributes. Constructor can also take parameters which is used to initialize attributes. Example of class. Here we have created a class called car, public class car. Here three variables are declared. This is color, which is a string type, model, that is also a string type variable, year. Year means year of manufacturing. It is integer type because it is a number. Then we have the constructor here, public car, string C, string M, integer Y. Here you can see this color variable is actually this one, and it is initialized by a variable C. And C, here you can see in this constructor we are giving this C, M and Y as input. So color is equal to C, that means user is giving some value which will come through this C and it will be stored here ultimately. And similarly model is M, here is Y. So this portion is actually, this actually color is different, you can see here. So this portion is constructor. Now we have static void put data. Put data is a method here. Put data simply printing the values of the variables like color, model and year. Here all these strings are just strings and that will be printed as it is, plus color. This is a variable. This variable actually it's coming here, model is coming here, year is coming here, and all plus signs are nothing but the symbol of concatenation. Concatenation means two strings, when they will be added, it is known in computer terminology as concatenation function. So here in this class example we are having attributes. These three attributes are there. We may call them member variables. We have a constructor. This is constructor function or constructor method, and we have a put data method. This is the put data method. With that actually this class will be finished. So it is started here. Another bracket is here, actually it's beyond the printing area, so it's not visible, but a closing brace must be there with this here. How to use the class? We have created the class, so that class must be used by a method. So main, actually this main is the main method of the Java program. So how to write this coding? Public static void main string arguments. We have car, my car is equal to new car, red, Hyundai item 2020. So using this statement we are creating one object which is known as my car. My car is nothing but the object of class car. This is the class, and this new actually it will call the constructor of the class. That means a new object will be created. But what are the attributes of the car? Attribute color is red, model is Hyundai item, year of manufacturing is 2020. Here you can observe one thing. First two variables are string type, so it's in the inverted quote. The third variable, which is year and it is integer, so it do not require any double quote. So this part is object creation part. Then member method is put data. So put data will be called by the object itself. So this is the object myCard.putData. That means we are calling the public method of the class by using the object. And after running the code, the output will be like this: car, color red, model Hyundai i10, year 2020. Then what is the Java class hierarchy? In Java class, object is the base class to all other classes. If we do not explicitly say extend in a new class definition, it implicitly extend objects. The tree of classes that extend from object and all of its subclasses is called the class hierarchy. All classes eventually lead back up to object, and this will enable consistent access of objects of different classes. Ultimately, what is the meaning of this Java class hierarchy? That means object is the base class to all other classes. Object is the main thing in the class hierarchy. You might have seen in the example, the put data method is called using the object. That means without object we cannot access the member variable or member method. So object is the final thing, last thing you can say. So in a class, object is the main component which is used to access the data. Without that, other information cannot be retrieved. Here is a link, web link for running the sample program. You can use this available link, www.w3schools.com. You can run the program in the web page itself. Now we are going to the next topic. It's nothing but the inheritance. For you people, inheritance is very common thing in biology, in life science. Inheritance is nothing but the child when a child is born, it gets some property by default from his or her parent. So that property is nothing but the inheritance. So similar thing is there in computer science. In object-oriented programming also we have inheritance. Methods allow to reuse a sequence of statements. Again, this word is there, reuse. That means reusability feature of object-oriented programming. Inheritance allows to reuse classes by deriving a new class from an existing one. The existing class is called the parent class or superclass or base class. The derived class is called the child class or subclass. The child class inherits characteristics of the parent class. That is, the child class inherits the method and data defined for the parent class. That means a child will have its own properties like own methods and own variables. And when the child inherits some property from the parent, whatever parent will have, that property will be automatically inherited to the child, so that the child will have all the member variable which it has plus the parent plus the member variable which is inherited from parents. So that is nothing but a reusability feature in object-oriented programming. Let us see what are the type of inheritances in object-oriented programming. The first type is single inheritance, where a base class is there and a derived class is there. Derived class, that means the child class. Base class is the parent class. So only one parent, one child. So this is a single inheritance scenario. Next we have multiple inheritance. Here we have two base classes. This is one base class, this is another base class, and we have a common derived class. That means this is a child from these two parents. Multi-level inheritance, that is another type of inheritance where base class is there, derived class 1, then derived class 2. That means 3 level of inheritances: grandfather, father, and child. So this child is getting property from parent, and this parent is getting property from his parent. So ultimately the child is getting property from both parent and the grandparent. So it is multi-level inheritance. That is also very common in object-oriented programming. Hierarchical inheritance, that means there will be some hierarchy. It is again very commonly used inheritance. It is a very real-time inheritance. Example, if we want to design a software for an organization, hierarchical inheritance must be used there. Even in university, suppose there are hierarchy. So if we automatize the university system, we have to use the hierarchical inheritance there. So hierarchical inheritance means one base class and number of derived classes, and it may continue. That means this derived class may further be extended to next level of derived classes. So in that case, that hierarchical inheritance can be called as tree structure inheritance also. Then we have the next type, it's hybrid inheritance. Hybrid inheritance, it's a complex inheritance example. Why it is complex? Because derived classes, these two derived classes, they have a common parent class or base class. They are getting properties from this base class. Again, they have a common derived class in the next level. So what will be the problem here in this class? This derived class is getting property from these two. Again, these two, they are getting properties from this base class. So the third level derived class will have multiple copies of the properties of base class. And that is the complexity. And that's why there are other techniques to handle this kind of duplicacy in the third level of derived classes. So this hybrid inheritance is used, but it's a rare occasion. It is not frequently used. We have an example here, example of inheritance. Here again, we have created a class vehicle with a member variable brand. Brand is again string type, protected one. We are coming to that classifier or modifier, protected, public, and we will discuss public, protected, and private modifiers, class modifiers. So brand is here initialized with Ford vehicle attribute, and then we have this method public void honk, which is actually printing out toot toot. One string will be, this string will be printed. Then class car extend vehicles. That means we are extending it to vehicle, and this private string mode name Mustang car attribute. Then main function is there. We have created this my car object, new car. Then we are calling mycar.honk. That means this member method is called using the object. Then system.out.println mycar.brand. That means brand, this brand will be printed, and mycar.mode model name, model name will be Mustang, this one. So it will print Ford and Mustang, these two things. And ultimately this one will print toot toot, and this portion will print Ford and that Mustang, this two. So that will be the output. So Java modifiers, as I have told in the earlier slide, that what is Java modifier? In Java we have three types of modifiers: public, protected, and private. And one default modifier is also there. So public class car, we have seen it is in the example. What is that public meant for? The public keyword is an access modifier. Meaning is that it is to set the access level for classes, attributes, methods, and constructors. What does it mean? Public means it can be used by any other classes without any permission or anything. Protected is bit protected data. It's not accessible for all, but yes, it can be inherited, it can be accessed by other variable on demand. And what about the private variable or private modifier? Private modifier means it cannot be accessed by any other class other than the class. So there are two groups of modifiers. One is the access modifiers, control the access level, and non-access modifier that do not control the access level but provides other functionality. There are some non-access modifiers. Final means attributes and methods cannot be overridden or modified. Static, attributes and methods belongs to the class rather than an object. Abstract, that is also another modifier, can only be used in abstract class and can only be used on methods. The method doesn't have a body. For example, abstract void run. So this way, if we write the definition of any method, that method will be considered as abstract method. Then transient, it's very rarely used. Synchronized, volatile, these are also very rarely used. Mainly static and abstract, these two non-access modifiers are used frequently. So that is the end of the class 2. We will have the class 3 very soon. So hope you have enjoyed the class 2. If you have any confusion on the class 2 topics, you can contact me in my email ID or in my WhatsApp number. Thank you.